Welcome back to part 2 of our video series about life cycle assessments. If you've been with us up to this point, you know that this part of the series has been all about the LCA phases. So far we've looked at the goal and scope definition phase, and most recently, the life cycle inventory phase. Now we continue on with the third phase, the LCIA. LCIA stands for Life Cycle Impact Assessment, and it involves exactly what the name describes. Evaluating the environmental impact our product system will have using the results we collected from the LCI phase. And that's what we're going to explore today. But let me just take a minute before we begin and reiterate something we've sort of mentioned a few times during our conversations together. Sometimes the goal of the study can be satisfied by omitting the LCIA altogether. In this case, your LCA study is more accurately called an LCI study, and it implies that we are more interested in the inventory than the impact. It's as simple as that, and sometimes that's what your situation calls for. But let's assume that your goals align with identifying or altering the environmental impacts of your product system. Let's take a look at what that looks like, and how it is accomplished according to the ISO 14040 and 14044 standards documents. To start things off, let's just ask a simple question. What is the LCIA phase, and what's it for? The ISO standards tell us that this phase provides a system-wide perspective of environmental and resource issues for one or more product systems. The LCIA contains procedures for collecting information on environmental issues associated with the inputs and outputs of the product system. Now, what does all of that mean? Essentially, the LCIA assigns LCI results to impact categories. For each of these categories, we select an impact category indicator. Each of these indicators has an associated result calculated, and the collection of these results provide the relevant information that we obtain from this phase. This collection of results is referred to as the LCIA profile. Let me just make an additional point about the role of the product system before we dive into the structure of this phase. At this stage of the study, we may need to make some interpretations about the elementary flows that cross the system boundary. Depending on how you've defined your goal and scope, these interpretations may be drawn from the LCI data results and used as direct input to the LCIA. If you've seen the LCI video, you'll recall that we talked about handling the raw data after collection and preparing it for subsequent phases. This usually involves converting our data into flows that follow from the definition of the function unit through the various unit processes, and then of course allocated between systems if we deem that's necessary. This is just a recap of what we've looked at recently and how it applies to what we're doing now. Alright, let's begin as always with a quick overview of this video's topic, our impact assessment phase. The name sort of belies the intent in this case, right? The LCIA evaluates the significance of potential environmental impacts using the LCI results we generated from the last phase. In general, the LCIA associates our existing inventory data with specific environmental impact categories and category indicators. These are two concepts we'll explore a little later in a bit more detail, but we've already mentioned that when we take these two things together, the categories and the category indicator results, they make up what is called the profile of the LCIA. Now, this is all in an attempt to understand the impacts of our data in real terms. Once we're finished with this phase, we will of course pass the LCIA profile forward to the next phase, which is the life cycle interpretation phase, and continue on with the study. Now, I've said this before, but let's take a second to recall that the LCIA is different from other techniques you might be familiar with, like environmental performance evaluation or other environmental impact or risk assessments. This is because the LCIA is a relative approach. Relative, remember, because we base our flows on a reference flow derived from our functional unit. This being said, you're able to perform these other environmental techniques alongside the LCIA if you wish, and feed any information you gather into your lifecycle assessment. It's really up to you and your needs. Another important thing to mention up front is the possibility of including subjectivity in your impact assessment. Subjectivity can be introduced through things like choice, modeling, and evaluation of impact categories. This flexibility is nice, but we also continue to understand this key reason of why LCA transparency is so critical, so that you can ensure your assumptions are clearly described and being reported properly. This is something we've heard before, of course, but here in the LCIA, it's another opportunity to mention it, and it's important. So here we are mentioning it again. And besides, if you remain clear and thorough and honest in your calculations and your reporting, it will never be an issue anyways. And of course, you may have guessed already that once we finish the LCIA, we may in fact not be ready to move forward into the interpretation phase for whatever reason. In this case, the LCIA may be extended to include review of the goal and the scope. This is in keeping with the iterative nature of the LCA, right? And it's consistent with our mindset in that the point is to determine if the objectives have been met, or whether we need to modify them if the assessment begins to indicate that they cannot in fact be achieved. Alright, now we've armed ourselves with a little bit of knowledge about what the LCIA looks like. Let's move on to how to plan and design for this phase of the study. And realistically, the planning portion can begin even while you're carrying out the LCI, the previous phase. This way, by the time you're actually ready to execute the LCIA, you've had some time to set good boundary conditions and refine your plan somewhat. And indeed, this is our first note. The LCI phase should be planned first and foremost with the goal and scope of the LCA in mind. Our ultimate desire, after all, is to fulfill those guidelines we set out right at the beginning. We also want to coordinate the LCIA with other phases and account for any omissions and sources of uncertainty that we may have run into. Such anomalies might include some of the following. First, whether the quality of the LCI data and results is sufficient to conduct the LCIA in accordance with the study goal and scope definition. We just sort of mentioned this in passing, and we'll say it's likely that soon after you begin your LCIA, you'll know whether or not you need to iterate back to a previous phase. Second, whether the system boundary and data cutoff decisions have undergone sufficient review. Remember that we reviewed our system boundary during the LCIA phase to ensure it was of ample scope to capture our target flows. Now we want to ensure that the availability of our LCI results are sufficient for calculating our indicator results within the LCIA. Finally, we want to know whether the environmental relevance of the LCIA results becomes decreased when we perform various things. For example, if we manipulated our data on a system-wide basis through averaging or aggregation, or whether we saw better results after allocation in the LCI, or when we performed any other calculations in the LCI that derive from the functional unit. You'll recall that these are things I've mentioned that you should be tracking as you perform your study. But if you don't have this information, this is where you would want to start to produce it. Now, there are no generally accepted methodologies for consistently and accurately associating inventory data with specific potential environmental impacts. There are some models for developing your impact categories, and depending on your industry or the metrics that you're interested in, you'll find that these models are going to be in different stages of development. You'll also find that the LCIA addresses only the environmental issues specified in the goal and scope, which makes sense. It seems trivial to say this, but it is important to remember that the LCIA is necessarily not a complete assessment of all of the environmental issues in the product system. This means that it cannot always demonstrate significant differences between impact categories and the related indicator results of proposed or alternate product systems. There's some good reasons for these limitations as well, and their presence does not undermine the analysis. We just need to be aware of them. Some of the reasons for why they arise we can address, some of them we can't. Let's quickly take a look at some of them just to complete the picture. We may have a limited development of our characterization models, for example, or our sensitivity analysis, or uncertainty analysis for the LCIA phase. These are elements we'll address later. We may have limitations in our LCI phase, such as those that arise when we adjust our system boundary. such that we might not encompass absolutely everything we need to consider. There might be cutoffs or data gaps that prevent us from including all possible unit processes for a product system, or all of the inputs and outputs associated with those unit processes. Other LCI limitations might include inadequacies in the data quality. These might have been caused by uncertainties or differences that occur in your allocation and aggregation procedures. There might also be limitations in the collection of inventory data that is appropriate and representative for each impact category. As a side note to this, any lack of space and time dimensions in the LCI results can introduce uncertainty in the LCIA results that vary with those spatial and temporal characteristics of each impact category. So, there's quite a few things to keep in mind, and you might be starting to understand why I've been so insistent that you track deviations from the standard procedure, documenting absolutely everything you can about methods you perform and assumptions you make, and iterating back on your study model to ensure that the results of one phase are clear and complete before formally moving on to the next. Right. So that's what we need to know in preparing for the LCIA. Now, what does this phase actually look like? The LCIA consists of two classes of elements, mandatory and optional. The names sort of say it all. The mandatory elements need to be included, and the optional elements should be included only if they assist you in fulfilling the goals of your study within the defined scope. Let's take a look at the elements within these two classes in a little bit more detail. Starting with the LCIA mandatory elements. There are 4 of them in this category. Selection, in which we will choose our impact categories, category indicators, and characterization models. Classification, in which we assign each piece of our LCI results to one or more of our selected impact categories. Characterization, in which we calculate our category indicator results. And the 4th element, if you'd like, occurs where you combine your calculated category indicator results with the other results of the LCIA into the collective and finalized outgoing LCIA dataset, which we label as the LCIA profile, if you'll recall. Alright, so let's start with selection, which sort of functions as a step 0, if you like, in that it sets up the steps that follow it. But that being said, I don't want to understate the importance of this phase, so there's a few things we do need to consider. First and foremost, you do not have to build your categories, indicators, and models from scratch. There are frameworks out there that address many different industries and the special needs associated with given processes or products. If you do select existing elements, make sure you reference them properly. This research will ensure that you're using these elements correctly and appropriately, and the readers of your work can better understand your methods. If you find that nothing else works for you that exists, well, you can always develop your own, in accordance, of course, with the guidelines we will be exploring. Now, when you're setting up your impact categories and your category indicators, you should make some sort of justification for their selection based on the consistency with the goal and scope of the study. Give them a descriptive name, and make sure they reflect all of the environmental issues associated with your product system. Once they're set up in this way, we're ready to fit them into a characterization model. Here's a bit of a breakdown of that process with the help of a graphic. This image illustrates the concept of category indicators based on an environmental mechanism. Every impact category has its own environmental mechanism. Characterization models are sort of in between the two, in that they reflect the environmental mechanism by describing their relationship with the LCI results, indicators, and in some cases, the category endpoints. Essentially, the characterization model is used to derive the characterization factors. That's a topic we'll touch on a bit later. And meanwhile, the environmental mechanism is the total of the environmental processes that are related to the characterization of the impacts. Recognize here that the model you choose and the related environmental mechanism, these two things relate each piece of your LCI results to the category indicator and provide a basis for characterization factors. You should provide a justification as to why the model you use is appropriate for deriving the category indicator in the context of the goal and scope. Now, so far in our discussion about selection, we've looked at how to identify or define the various mandatory LCIA elements, and it's worth taking a second to recognize that we've done things in this way to facilitate our modeling and make it easier to collect and assign appropriate LCI results. You might not quite see it just yet, but this procedure helps to highlight the study's validity, while yet still allowing us to address externalities like our assumptions, like our value choices, and the degree of accuracy or inaccuracy in the characterization model. In short, it is proper procedure that allows us the maximum possible depth and flexibility when moving between the LCI and LCIA phases. Here's a few more points to consider, and then we can wrap up our talk about selection. First of all, the environmental relevance of the category indicator or characterization model needs to be clearly elucidated. The primary way of doing this is to comment on the ability of the indicator to reflect the consequences of the LCI results on the category endpoints, at least qualitatively speaking. You'll also want to include additional environmental data with respect to the model's impact on the category endpoints. Now, this could include a lot of things, whether there are conditions on the endpoints, for example, or the relative magnitude of the assessed change in category endpoints, spatial aspects like area and scale, or temporal aspects like duration, persistence, residence time, whether the environmental mechanism is a reversible one or not, whether you have uncertainty when it comes to linking your indicators and your endpoints. Essentially, you need to spend some time justifying why the model you've selected is the best tool for fitting your LCI results with the chosen category indicators. You'll also find that many of your LCI results can be broadly classified as mass flows or energy flows. And if that's the case, you can do what we've discussed so far. But if you have LCI results that are derived from something other than mass or energy flow data, something like land use or economic impact, you'll need to spend some time explicitly identifying them, as well as explaining their relationship to corresponding category indicators. Once again, this is for non-mass, non-energy flow data. And finally, ISO also provides several recommendations to follow when you are selecting your categories, indicators, and models. The first one is perhaps the foremost, because when we're selecting our categories, indicators, and models, the ones we are choosing should be internationally accepted, like based on an international agreement or approved by a competent international body. Second, your impact categories should represent the aggregated impacts of inputs and outputs on the product system and on the category endpoints via the category indicators. Third, try to minimize making value choices and assumptions during the selection of your categories, indicators, and models. LCA is a bit freeform, as you know, but this is just not the ideal step in which to exercise that freedom. As we mentioned before, it's far better for this particular operation to follow the proper procedure. Fourth, try to avoid double counting in your categories, indicators, and models unless it is explicitly required by the goal and scope. The perennial example for this exception is cancer-causing substances, which are typically tracked through both human health and carcinogenicity. Fifth, and I quote this one from the standard, the characterization model for each indicator and its associated characterization factors should be scientifically and technically valid and based upon a distinct, identifiable environmental mechanism and reproducible empirical observation. That all means that if you select a model that already exists and is relatively popular and credible, you probably don't have to worry so much about this point. But if you create your own model, you need to ensure that it has been constructed rigorously and reproducibly. And last but not least, the LCIA category indicators should be environmentally relevant. Don't waste your time and resources at this stage in the LCA by analyzing something that won't be relevant when we move on to the next phase, which is where we start interpreting our results. Alright, that was selection, the first of the LCIA mandatory elements. There was a lot to say about it, I'll admit. And fortunately, the next element is a little easier to understand and explain: classification. Recall that this is the act of assigning LCI results to your selected impact categories. This is a pretty straightforward procedure, and it follows directly from your LCI results and the preparatory work that you put in during the selection step. While you're assigning your results to categories, keep in mind a few considerations provided by ISO. First, you should make an explicit differentiation between LCI results that are assigned exclusively to one category and those results that are assigned to more than one category. The criteria for making this differentiation should follow from your goal and scope. And further, you should avoid making this differentiation only if it is so required by the goal and scope. With that being said, go ahead and plug and chug, take your relevant results and start classifying them. One thing to keep in mind: if you are assigning LCI results to more than one category, you should make a distinction between parallel and serial mechanisms. So let's take acidification as an example. On one hand, sulfur dioxide might get apportioned between human health and acidification. This is an example of a parallel mechanism. On the other hand, nitrogen oxides can lead to higher levels of ground-level ozone, which in turn contributes to acidification after the fact. This is an example of a serial mechanism. Alright, our third mandatory LCIA element is characterization, which is the calculation of your category indicator results. More to the point, it involves the conversion of LCI results to common units and the aggregation of those converted results within the same category. This conversion uses the characterization factors you developed during the selection process, while the outcome of the calculation is your indicator result in numerical format. Remember, when you are calculating your indicator results, you should clearly identify the calculations and their outcomes, including any assumptions or value choices that you used. Now at this point, we're getting deep into our analysis, and you may start to find that some of your LCI results are unavailable or that the data are of insufficient quality for you to achieve your goal within the scope of the study. This is where you'll need to make a choice. Either you need to iterate on your data collection to kind of beef up your data set, or you can make an adjustment directly to the goal and scope of your study using that iterative process. Whichever you decide on, be sure to document it fully before moving on. Now, assuming you're happy with your data set, we still need to address how data is being handled at this stage. For example, you may have surmised that the usefulness of your indicator results are directly dependent on the quality of your characterization models and factors. There's certainly a trade-off between the simplicity of the model and the accuracy of the results, no doubt, and we recognize this from other analytical methods. On top of that, the types of simplifications or assumptions you use in a given model might also vary between categories and might even depend on the geographical region in which you make them. All this and more to say, if you find yourself getting stuck at this stage, maybe you can't quite map or calculate your data accurately, or you're running into issues of categorization, say, and it's making the characterization difficult, you'll want to refer back to the standards in this case. There's a whole list of guidelines and suggestions that deal with several broad issues, and you might find some helpful advice here for your own product system. There's also supplemental readings published by ISO that I've mentioned before in an earlier video. I'll stick a quick graphic here in case you want to check them out, just as a quick reminder. Also, if you're able to add any additional data about the environmental conditions in which the data collection was performed, this can enhance the meaning and usability of your indicator results. You can also deal with this consideration later in the optional LCIA elements during the data quality analysis, if that works better for your study. Now, the last mandatory element is compiling the LCIA profile, which is the collection of calculations and results from the LCIA process we just went over. But let's detour quickly to the optional elements before we draw everything together at the end. Let's check in with where we are right now. After characterization, but before the optional LCIA elements that we're about to discuss, the inputs and outputs of your product system should be in a somewhat final state, final in quotation marks. For example, you might have a discrete compilation of LCIA indicator results, and each one is assigned to different impact categories. Once again, if you stopped the LCIA phase here, this is what you would call your LCIA profile. You might also have a set of inventory results that have associated elementary flows, but they haven't been assigned to any impact categories, maybe due to a lack of environmental relevance or something, right? And finally, you might have another set of data that is not representative of elementary flows and doesn't really fit in anywhere else. So at this point, you might want to try and tie up the loose ends present in points 2 and 3 here. You might also want to work with the data already in your LCIA profile and modify it in a way that's easier to assess when we move on to the next LCA phase. With this in mind, let's shift our focus to the optional elements of the LCIA phase. You should choose from these elements depending on the data you do have, like we just discussed, and the goal and scope of your study. So the point in choosing these is ensuring that your results make the most sense moving forward. The optional elements are set up in a way that they allow you to use data and information from outside the LCIA framework to help augment the data set that you're working on. So if you do include these outside sources, be sure to include an explanation of which ones you've included and why in your study report. But it's important to remember that you can use them in conjunction. Now, a final note before we explore the elements in detail. These elements are more or less mathematical in nature. This means that you'll need to invoke some sort of method for performing these elements, and of course, calculations that will help you obtain a derivative result. And for transparency's sake, any methods and any calculations that you use should also be well documented in the report. Okay, with that said, let's dive in. The optional elements of the LCIA. First up is normalization, which is the calculation of the magnitude of the indicator results relative to some piece of reference information. The whole point of it is to get a better understanding of the relative magnitude for each indicator result inside of your product system. You can use it to check for inconsistencies, for example, or to communicate information about the relative significance of your indicator results. If you're familiar with normalization in science or economics or mathematics, you know that it's usually done by dividing your unnormalized value by some reference factor. That's how we end up with analogous things like normalized interest rates, or normalized unit vectors in space, let's say. It's basically the same thing here, where you divide your indicator result by a selected reference value to get a normalized value. Now, you can't just choose any system for your reference, of course. The selected reference should best consider the consistency of the respective environmental mechanism with respect to your space and time parameters. At this point, you should check out the standards for more information, including the sensitivity analysis that you should perform when carrying this out. The second optional LCIA element is grouping, which is the assignment of categories into one or more sets that might be predefined in the goal and scope definition. It might also involve an element of sorting or ranking, but do keep in mind that there's no good reason to reduce the result of your entire LCA into a single metric or number. To put it another way, a grouping operation should not result in the reduction or abstraction of data, merely the categorization of it. You can do this in one of two ways. Either sort the categories according to a hierarchy, something like high priority, medium priority, low priority, or you can sort them on a nominal basis. This can be accomplished by looking at certain characteristics like inputs versus outputs, or by geography, say by looking at different scales, local, regional, global, things like that. You can see that these sets of categories are, again, not trying to encapsulate the data, but rather delineate them according to natural orders or groups. Now, if you do decide to rank the categories, 1, 2, 3, high, medium, low, you need to recognize that ranking anything has an element of subjectivity and circumstance, and therefore any ranking is based at least partially on value choices. Different parties might have different preferences, and so it's worth keeping in mind that it is therefore possible that different people will reach different rankings based on the same normalized or even unnormalized indicator results. The third optional LCIA element is weighting, which is the process of converting indicator results of different impact categories by using numerical factors based on value choices. That's a bit of a mouthful, but let's focus on the last part for just a second. Value choices. Weighting steps are not scientifically based, and you need to recognize that right up front. Much like grouping, weighting is rather subjective, and different people view different things as more important or less important than other things. And so we should expect different results from different parties. Again, this is just something to keep in mind. The process of weighting has two steps, kind of, and they can be done in any order, sort of. Let me explain. The most important step is to convert the normalized or unnormalized indicator results to some other value using a weighting factor. This is consistent with what we would call weighting in other disciplines like statistics, for example. The second step is optional, and it involves aggregating your results across the impact categories. You can aggregate them before you weight them, you can aggregate them after you weight them, you don't have to aggregate them at all. It's really up to you and the requirements of your study as specified in the goal and scope. If your product system is particularly sensitive, for example, you may even want to use several weighting factors and a few different methods just to see what combination works best. This might necessitate, of course, that you conduct a sensitivity analysis to assess the consequences of those different choices on your LCIA results. Now, just a last point about weighting. It is unique in the optional elements in that all of the data and indicator results that you had prior to weighting should be made available together with the results you have after weighting. This applies for both normalized and unnormalized data. This extra bit of detail ensures that all of the trade-offs inherent in this very subjective process remain available to decision makers and to others, and that they can appreciate the full extent and ramifications of the results. So, very good. Once we're done with normalization, weighting, and grouping, we can move on to the last optional element, and it's rather a collection of elements. This is additional LCIA data quality analysis. If you've carried everything out so far and you still feel you need a better understanding of your results, you might want to look into some of the techniques that we'll mention here. You might need help distinguishing the significance of a result, for example, or whether it's negligible, on the other hand. You might have questions about certainty or precision or accuracy, or you might recognize that your data is insufficient and you're ready to iterate back into the study and you simply don't know how to proceed in doing that. ISO lists some suggestions for techniques you can use, and their use, of course, depends on the amount of detail that you still need to fulfill the goal of the study in accordance with the scope. For example, there is a gravity analysis, which helps identify the data that contribute most to the indicator result. These items can then be investigated with increased priority. We also have uncertainty analysis, which helps determine how data uncertainty and any assumptions that we've made propagate themselves through the calculations and how they might affect the reliability of our LCIA results. We can also perform a summary sensitivity analysis, which we've talked about sensitivity analysis at other points during the LCA. If you don't already know, or if you've forgotten, it's a procedure to determine how changes in the data and methodological choices affect the LCIA results. That is, in a nutshell, the method for carrying out an LCIA. I have one final point I need to make, and it's very important, and it's for LCIAs intended to be used in comparative assertions intended to be disclosed to the public. I always love trying to get that out in one breath. Remember that this is a special condition that ISO points to as a way of flagging potentially biased information when it is going to be released to lay people. I say biased, what I'm referring to is the subjectivity of steps like weighting or grouping, or the value choices that we make when making certain categorizations or aggregations. We've said different people can view the same thing different ways, and we need to make this explicit to the public when there's an opportunity for them to read our conclusions. Now, there's a raft of additional considerations that you need to incorporate in your study if your LCIA will indeed be released to the public. I won't go over all of them here because I realize this won't apply to all of you, but I do want to take the time to make 2 quick points. The first is with result to the optional element of weighting. If you're using your LCIA results and making them public, you cannot use weighting, period. It's just way too easy to make the results say whatever you want, which is fine, I guess, to a certain extent within a firm, say, where you might have to corral the data towards a specific endpoint. And as we've just discussed, the optional LCIA elements are a way to do that if the data is being, shall we say, uncooperative. But if you're releasing your results to the public, weighting is a big no-no. It's just too easy for bad actors to misrepresent things. The second point is with regards to your category indicators. For publicly released LCIA results, your indicators should be, at minimum, internationally accepted, scientifically or technically valid in that the associated environmental mechanism is identifiable and empirical and reproducible, all that good stuff. And they should be environmentally relevant, with clear links to the category endpoint. That's kind of in line how you would usually craft a custom characterization model, but note that in this case it is an explicit requirement. So that's the video for the Lifecycle Impact Assessment phase. As always, thanks for hanging out and learning a bit more about product LCAs. In our next video, we'll move on to the final executive phase of the LCA, the interpretation phase, where we figure out what exactly we've determined during the course of our study, and how we can ensure that we've accomplished our goal in accordance with our scope. I can't wait to share it with you. I'm Jamie Frendo-Cumbo with EnviroPass. Thanks for watching.